main message I got out of it is that I might actually
Good afternoon, everybody. I'd like to welcome Bhuvana Ramabhadran today from IBM. She's going to talk about, the title of her talk is MALACH, Multilingual Access to Large Spoken Archives. Some of you may know that Bhuvana is working on the IBM side of a large NSF project that just started that will involve CLSP, University of Maryland, and the Visual History Foundation in Los Angeles, and Bhuvana will be speaking today about that project. Thank you.
Thank you, Bill. Good evening. So I'm going to be talking about Malach, and the meaning of that word Malach is angel in Hebrew. And as we get into the talk, you'll probably get a feel of why we named the project with this acronym. Anyway, it stands for Multilingual Access to Large Spoken Archives. I'm from IBM's Yorktown site from the Human Language Technologies Department. And a couple of people who have been working with me on this are Michael Piceni and Martin France, primarily from the Information Retrieval Group. So here's a brief outline of my talk. I'm first going to give you a little bit of motivation into what got us started in this project, or what are we going to do in this whole project, what are our specific goals. I will spend some time talking about some previous recognition experiments that we've run on a little bit of the sample data. We'll give you a performance on the current state-of-the-art systems on this data. And I think what will be a little more interesting is what kind of recognition errors we make, what are the examples of, how does this whole archive look like, what are we talking about here? And I'll get on a little bit into detail as to, given this particular project, what each site in this project is going to focus on, and what we think the impact of this project is going to be for the future of technology in general. So with that in mind, what is this data all about? VHF stands for Visual History Foundation. The actual full name is Survivors of the Showa Visual History Foundation. This was founded by Steven Spielberg, and as the goal of this foundation was to develop a huge oral history archive based on actual experiences of several of the rescuers and survivors of the Holocaust. So what they did was they collected testimonies from various individuals. It was a big effort in even to locate these people and try and get them to interview for the collection of this database. So this was a huge operation. They spoke to about 52,000 individuals, about 2.5 hours each from each one of them. And they collected data in over 32 languages. If you want to know how big the archive is, it's about 180 terabytes of digital video. So there was a lot of investment in just building this whole digital library, in putting the infrastructure in place to be able to retrieve a particular speaker and listen to the video testimony before even you could do anything else with the data. Now, their goal was to get this information across to as many individuals as possible, teachers, scholars, students, disseminate information as to how you can reduce violence in society today, what happened during the time of the Second World War, any kind of information you could possibly retrieve that's not available in any other kind of historical archive. This is an oral history archive, which means it'll have a lot of people talking about their actual experiences, what happened, which is not documented elsewhere in any other database. So their goal was to put this whole set of interviews in some sort of a database fashion that people could search through and look for people's names or concepts or places where things happen. And for that, they first had to catalog all of these testimonies. So I'll get into the process of how they catalog these testimonies, but what they did was about 4,000 of these in English. And they came up with about 21,000 keywords to describe these 4,000 testimonies. And it cost them about $8 million to do this in about 5 years. So here's an example that you see here of what a person actually said. The person was clearly talking about some living conditions in a few camps, what a ghetto procedure was like, and this person is actually talking about a formation of a Jewish committee that he was in. And so this is like a typical representative of what a person might say. And this is like an interview, so the interviewer starts off by asking the person questions on first, where was he born, you know, what year was it, and how many people were there in your family, did you have any brothers, sisters, what was your profession, when did you get into the ghetto, and the conversation leads on, and then they tend to speak by themselves after a particular period of time. So there are some segments where people are pretty fluent, and you can, you know, pick out a passage like this and say, okay, what are the terms that are being spoken about here? Conditions under German occupation, ghetto procedures, and Jewish committee. So what the foundation did in the cataloging procedure was they extracted segments like this and assigned to those segments these kind of thesaurus terms, what we will refer to as metadata or keywords as maybe. And if a person wanted to search the database afterwards, he could possibly ask for, tell me about ghetto procedures in the year 1939 or something like that. And it would pick up all segments which have been cataloged with ghetto procedures or with 1939, and this would end up in a lot of useful information. So this was the goal of the foundation, and they were doing all of this manually. And I'll tell you a little bit about the data collection itself. All of the interviews were recorded on a Beta SP, which is a production quality format, and they were subsequently digitized into MPEG-1 video. The foundation has put out documentaries in a few languages based on the 4,000 testimonies they have cataloged, and some CD-ROMs with just raw testimonies themselves. The cataloging database standard that they used was something called Z39.19, and this is a standard DB2 database standard that they conformed to. They did interact with other digital libraries to see if there was a better standard that they could use, and eventually settled on this for purposes of what they were trying to do. I mentioned that they had a lot of languages in their database. So here's a distribution of the number of testimonies they have per language. So English was the highest number of about 25,000. The next highest was Russian, followed by French and Spanish and Hungarian, Polish and Czech and Slovak. And you can get all of this information from their website, which is vhf.org. They have listed out their cataloging procedures, what data they have, and the distribution of the other languages. Okay, so how did the catalogers actually do this cataloging? They would listen to segments of data, so they would divide this entire 2.5 hours into small segments of like 1 to 3 minute chunks, and as they went along, they would take 1 or 2 3-minute chunks, listen to it, make some scratch notes as to what they think the person said, and maybe things weren't clear or the person wasn't coherent, so they would go back a little bit, listen to it again, or maybe rewind back a good distance to get a context of what the person was saying and make some notes. And then they would write down the terms like a place was mentioned, a name was mentioned here, or this is the concept they were talking about. And to assign, if it was a name or a place that didn't already exist, they would add it to their thesaurus, which had the list of metadata information. If it was a concept, they would also pick it out of there. If it's something that didn't exist before, they would actually enter into consultations with linguists and other oral historians over there before they decided if they needed to add a new term to the thesaurus. So now you can imagine what an extensive procedure this would be, and this is why it cost them so much and this much of time it took to catalog these 4,000 testimonies. And also they had to do things like in the process of the interview, they would collect stills, they would collect artifacts that the person had from memories of the Holocaust, and they would associate these with those particular segments. So all of this took some time in doing the whole procedure. And in the end, they would summarize the entire testimony. Now, they have improvised on the scheme a little bit to saying, we're not going to go back and forth and we're going to listen only to fixed 1-minute segments. This has a few ramifications, but it speeds up the process. And it's still going to be a very tedious process, so this is where our interest comes in. And this is what led to this whole project. So what is the goal of our whole project? This is to dramatically improve access to large multilingual spoken archives, and we specifically want to capitalize on the unique characteristics of this database. This is as unconstrained as speech can possibly get, because these people are being asked questions, they're having a conversation, and as they get into the interview, they get very emotional, they're describing their real life experiences, and it's really very good speech data that we can have for research purposes. And it's one of the very I would think it is the largest multimedia digital archive that exists of this kind of information. So in the process of analyzing this data, we decided to embark on this project, and these are the specific goals that we've come up with. I'll get into a little detail on who the we I'm referring to. So what is the first thing we want to do? We have this data and we need to catalog it. There is, all of the information lies in the spoken audio and in what the person said. Now, without having to actually listen to it, the only thing you can do is to automatically transcribe the data, hope that it's of a fairly decent accuracy, that you can do information retrieval work on it and automatically catalog the data, possibly generate new metadata to add to the database. And then you can think of doing a wide variety of user studies, and you can think of doing searching, exploration, and get into the field of analyzing the data you've already cataloged. Now, this was the original goal of the foundation, and we've split this into several specific goals. So first of all, we feel we can make advances in speech recognition technology to handle the spontaneous and emotional speech with disfluencies. It's very heavily accented. And given the time frame at which the Holocaust happened, almost all of the speech is elderly speech. And many of these people tend to switch between languages in the course of the interview. I mentioned that only 4,000 testimonies in English had been cataloged, which means we have the remaining languages we're cataloging in, and there is no metadata for the other languages. So the automated translation of the thesaurus comes into play here. We also need automated techniques for generation of new metadata, as well as to automatically catalog with existing metadata. And the final important user study that we need to do is to see what is the social and scientific value of such audiovisual archives. What are the various benefits we can derive from such an effort? So with that in mind, this is a project that has been funded by the National Science Foundation. And the consortium comprises of IBM, the Visual History Foundations, Johns Hopkins University, and University of Maryland. We have an award of about $7.5 million for a duration of 5 years. And these are the languages we propose to tackle initially: English, a few Eastern European languages starting from Czech, and with time permits, we hope to extend to French and Spanish. And the other Eastern European languages we hope we can tackle are Slovak, and there seems to be a lot of interest in doing Russian, so if we get our technology sufficiently advanced, maybe we can start looking at that as well. Okay, so here is a very, very brief block diagram in sort of the highest level.
No, before you go on, I had more questions about the corpus. So you said there are about 24-something thousand stories or interviews in English.
Yes.
Is any of it native English speech, or is it almost all non-native speakers?
If any of them were child survivors, then they did much of their schooling in this country, which means their English is very fluent and almost sounds like native English.
Is the data, is there metadata to say that these are the people who were young?
But you can get information about when this person moved to this country. You can get background about the education of this person as to, what was their primary language of education, where they were born and brought up. All of this exists in like a pre-interview questionnaire.
Okay.
So you could potentially draw conclusions based on this information to what you're eventually getting.
Does the pre-interview, it has places, does it have things like if they were in a particular camp, which one they were in, or?
Yes. They tried to prepare the person before the interview actually happened. So this was like a 40-page questionnaire that they ran through with the individual. And the interview was more along the lines of that questionnaire. So you find these things in the interview itself, like names of camps and everything, but also you could get some of the information from the pre-interview questionnaire too. And that's available in digital form, so we're hoping to get hold of that information as well. Okay, so here's a very, very high-level description of what we think the problem is. We need automated speech recognition technology, and we need to do cataloging and search, and we need to generate metadata, and all of them need information about the thesaurus metadata. So if you want to describe in a nutshell what this project is all about, what are the technologies that are involved in it, this is what we would present to you. These are the various components that we have, and this will all interact with the metadata thesaurus. if you went into slightly little bit more detail and try to see what do we have to do, we have the digital audio from the testimonies. We need to do speech transcription on it. Once we get the transcribed automated transcriptions or the manual transcriptions that we're going to get, we can do topic segmentation, named entity extraction, topic tracking, automated generation of metadata, all of that on that data. And then we can try our search and retrieval technologies on whatever comes out of that. So if you split it into what are the various components, these are the components, and this is how we organized our consortium also to do work on. Okay, I said I would talk a little bit about previous recognition experiments. Just to give you a little background, the amount of data we really had was like 2 or 3 speakers to play with, and we had a time duration of about a week to see what we can do with the current recognition systems. We had no training data. Our test data also was, like I said, little bit. And we had the experiments we did were on 1 good speaker and on 1 average speaker. Now, when I say good and average, when they gave us the data, they said, this person is sort of good, pretty coherent, but is not representative of the database, is more of an outlier. Here is a more of an average speaker who probably is a better representative of the database. So we extracted the audio from the MPEG-1 video and we took it into half-hour chunks. We did our transcription of this data, and we tried to fix some of the disfluencies in the half words and names and spellings of many of these words which we hadn't come across before, and we didn't even know if we were doing the right thing. So to transcribe about an hour of this data takes approximately 8 to 10 hours, 10 to 12 hours. So it's a very tedious process, and it's a very expensive process, and it does come out with some amount of transcription errors and requires subsequent verification steps to correct it. What were the recognition engines we used? We used our Broadcast News Hub 4 system, which is a fairly huge system, and it has a vocabulary of about 94K, trained on broadcast news shows. The second one we used was our via voice dictation system, which has been purely trained on read speech and spontaneous speech to some degree, but the spontaneous speech in via voice is stuff like people were asked to dictate to a machine. So they were put in a room and they were told to talk. So they would describe things like letters to their friends or list of things to do, or they would describe the most recent vacation they had. So it was spontaneous speech, but more of dictation-oriented spontaneous speech, wasn't conversational. And the LM we used on for the broadcast news system was from the broadcast news shows from CBS and NPR. And for via voice, it ranged from broadcast news shows to all the way to memos floating around with an IBM. Just a little bit more about the broadcast news system we used then. I believe this was the 99 system that we used because this happened around that time frame. We had a band limited system and a system with 16 kilohertz. And they were all 55 phone systems except for one which had a reduced phone set, which seemed to be a little bit more robust. They were all had Gaussian mixtures of about over 200K, and they were all 60-dimensional LDA-based systems. And we combined them with Rover. This was if you look up the definition of our Hub 4 system for 98 and 99, this is what was used at that point. Here I briefly talk about the data that was available to train the broadcast news system. We had CNN, ABC, PBS, and NPR News. I didn't touch upon how we segmented the data between the interviewer and the interviewee. So we used BIC-based segmentation for detecting the turns. To give you an idea of how this data is, the initial part of the data has a lot of speaker turn and switching because the person is asking, what is your name, when did you come, and also at the same time, the person being interviewed is sort of warming up to the concept, so is giving monosyllable answers and has to be prompted a lot by the interviewer. As you get into the interview and as they get into what they're actually saying, they become a little bit more fluent and they speak for longer segments without being interrupted. Except, of course, when they get very emotional, in which case they need some amount of prodding also. So our segmentation on some sections would do well, on some sections it would be abysmal. And then we would adapt our speaker-independent models to whatever segments we got out of this data. And remember, all of this is like 2 speakers, half an hour of data, that's all that we had to play with. For via voice, we used the same kind of BIC-based segmentation, but we also used our silence-based detection schemes, of which we have a few floating around for our desktop line of products. And we did the same thing of adapting the speaker-independent systems using both supervised and unsupervised adaptation. Now, in our ViaVoice product, we have something called enrollment, where the person reads a predefined passage, and we adapt our speaker-independent models based on that information to produce a speaker-adapted system. And so we tried to follow the same philosophy, and we tried to get some held-out data for the same speaker and adapt to it, and then try it out on test data. And we also did unsupervised adaptation, and you can see the performance on the two speakers that I have shortly. And if, what did I do for supervised adaptation with the ViaVoice? Now, we did a little bit more experiments with ViaVoice than the Hub 4 system, simply because it was easier to play with. It was much smaller in size, and we could turn around things faster, and we had about a week to see what we could do with this data. But primarily, all adaptation experiments are iterative MLLR. So what did we do for supervised adaptation? We tried to see what is the best number we can get out of this data, assuming that we had very ideal conditions. So we tried to extract speech segments from whatever data we had by removing all of the disfluencies, removing anything where a speaker stammered a lot or was very incoherent. OOVs is a big problem in this data, so we just got rid of segments with OOVs. We corrected transcription errors as much as possible and completely eliminated the speaker turn stuff by removing interviewer segments. And this is really supervised adaptation, because the goal here was to see, is there anywhere we can get with this data? And you'll see what I mean when you see some of the numbers. Okay, so those are error rates. The average speaker-independent error rate on the best Hub 4 system, which was, I believe, 18% on Hub 4 data, was about 74%. Good speaker was close to about 57%. Unsupervised adaptation brings it down to by, like 4% or 5%. And with the combined system I'm talking about Rover on the Hub 4 system. And the percentage of OOV we had on the data was rather high. For the average speaker, you can tell it's about 12%. And I'm sorry.
Can you tell me what OOV is?
Out of vocabulary words.
Okay.
So the recognizer's lexicon didn't include much of what the person said, which is in a totally different domain. And you can tell ViaVoice performance was about the same as the Hub 4 system, even though it was a much smaller system. And the best unsupervised adaptation number we could get on the good speaker is about 46%. Okay, so what can we do with supervised adaptation on the good speaker? We can get to about 35%. So we thought we had some hope that if we could actually train some of our models on data which is very relevant to this domain, we could actually get within acceptable error rates, and this would facilitate subsequent IR work. Now, information retrieval technologies work fairly well when you're operating at error rates of 35% or so. It's only when you get to like the 40-45 range that they really fall apart. So if there is a chance we can get to train this acoustic models, language models on this kind of data, then there is some chance that we can get within reasonable, acceptable levels of accuracy. So this was encouraging enough for us to go ahead and try to do some of the work. But let me get a little bit into the analysis of the errors. Now let me play the audio for you. This is what the recognizer output. Now you listen to what the person said, and
my middle name, my middle brother, he had two names before the war, Shlomo Hatzi. And me, when I was the baby at home. And the sister's name was Miriam. All the Russians.
This is very representative of the data. And I think it does a fairly reasonable job of phonetic transcription, but the words are a completely different story. Let me play.
Again? Can you play once again?
My middle name, my middle brother, he had two names before the war, Shlomo Hatzi. And me, when I was the baby at home. And the sister's name was Miriam. All the Russians.
I'm sorry?
I'm sure that this is not
This is the output of the recognizer.
Well, that's what I mean by OOBs also. A lot of times the transcribers spend a lot of time trying to figure out what the person actually said. Was it a name? Was he describing something? And so this sort of explains the complexity of it. Let me play some more examples.
President marszałek Łyjewiec.
Clearly, we didn't have that in our database, so we just put out some words we thought would fit in to eat up the speech. That was a good speaker. So let's get into the disfluency
You
range.
see what with your eyes, what you're doing, what's breaking down, what is that group, what that's group, that's it.
These are the kind of disfluencies you see in the data.
With the onset on our arm.
So let me move on here.
For the possibility of that the Germans are building up and threat.
So this was a good speaker, and but for the disfluencies, that segment was fairly good speech. So you can tell the speech is not very noisy in terms of the recording itself, but there are a lot of issues like this floating around. And since this is a very emotional experience they're describing, this is what you'll hear.
And young men, secretly figure out. They meet you.
So in some places you can barely hear what the person said. There's loud fluctuations in volume, and not only is it going to throw off our recognizer, it throws off a transcriber who basically marks things as unintelligible in which we cannot afford to live with, so they have to go back and forth, and it's one of the problems that we face in this data. Let me play a section here where there are a lot of frequent interruptions with the interviewer.
2 days.
These are the people who are to go to lunch, and your brother's loved himself.
So that's in a scenario where the person is trying to prod the person on to talk, the interviewee talk on a little bit more about what exactly happened, and you'll run into segments like this, and very often the person may not come back to this topic, so which means you could potentially miss topics if you didn't do a good job of finding out what the person said here. Clearly the person had a problem in talking about that particular whatever he was talking about there, so he had to be prodded along, and so he's not going to come back, and so there's frequent overlaps. And I would say this is the tough portions are very representative of the database that we have, and of course this is only English, so I don't know if the other languages are worse or about the same, but you can imagine that they're just about bad or good, as you want to say. Okay, so here's another little experiment we have time for. We took the transcriptions of these two speakers we had and had some very good native English speakers read this text. Of course, it was read speech, and they didn't quite have the emotion that the rest of them had. And leaving all of that aside, if you just got two very good native speakers to read, the performance of the system was 12%. So we could sort of isolate several of the problems we had based on that. And if you're wondering how much of the data is really disfluent, on the good speaker it's about 25%, on the average speaker it's more like 44%, so which means basically half of what the person says is very disfluent. And so this sort of points you in the direction of the areas in which we need to work on to improve this accuracy. Okay, what I have here is an example. I don't know if many of you can read it as to if things really get better. So the first column is the baseline, then you have unsupervised adaptation, then you have supervised adaptation, and everything that's in gray is the error part, which gets better as you go along. So, if you look at it for a while, you can see how some of the errors are being recovered. For example, if you look at this word parapet, you got it wrong in the baseline. You still got it wrong in this area in the unsupervised, and with supervised adaptation, you did get better. So you do recover some of errors like this, and many of your insertions go away. And so all that this tells you is, there is some hope to recover many of the errors we make, and gives you an idea of how you progress as you go along from doing different kinds of adaptation experiments on this data. Okay. Now, I mentioned topic segmentation. What does topic segmentation do? Here's an example of CNN news where different topics are defined with different levels of precision. So you can tell that the first topic is about something to do with Mr. Clinton, and then the next topic is about something to do with IRS, and so on. So now, what does topic segmentation have to do with this kind of data? Let's first get into a little bit of definitions here. Story segmentation, what do we mean by this? This is when you want to insert boundary marks into stories based on the automatic speech recognizer's output. So you want to say, for example, the person is talking about this story up to this point and then changing to another topic. You may come back to the same topic, in which case you need to be able to link back and do topic tracking. It's very relevant to this data because the person is basically talking about different features, and every topic here is really a keyword or metadata. We need to know when the person is going to switch to a new topic. Now, one way to do this is we know the interviewer is going to ask a question related to this. And another way is that the person just fluently goes on from while he's talking about a Nazi concentration camp, he's talking about how people educated themselves while being in that camp. So you have two different topics being spoken about in the same segment, and this is a big problem for IR because they haven't been used to this kind of data before. And the kind of sources they've been working with are, broadcast news shows, Mandarin sources, and the TD2 and TD3 corpus, which basically comprises of these shows over a period of time from in '98. Okay, so this is what we really need to do over an interview. The HM and EL are referring to two speakers. So initially they're introducing themselves. They're talking about maybe introduction of where they are from. They're from Warsaw. So these are the keywords that are going to be assigned to these segments of the testimony. Then they probably go on to talking about what their education is, what they did in the ghettos, whether they formed the Jewish committee. And then you have keywords such as ghetto, education, Nazi, Jewish, these kind of keywords being used. So these are all essentially topics, and you find that the same segment has several keywords or topics assigned to them. To give you an idea of how IR systems have been performing, on a Voice of America news broadcasts, with a precision of about 70%, working at automatic word error rates of 32%, they seem to be doing a fairly good job. 70% precision is considered pretty good, given that your raw data, input data, is at an error rate of 32%. So if we can get our speech recognizers to work at that accuracy, then we have a halfway decent chance of actually doing some good information retrieval work on it. This is a more recent graph on Trek 8 evaluation, comparing manual as well as ASR transcripts. And the precision numbers aren't that far away with each other. So we can tell that on this kind of data that they were fairly close, but it could be a completely different story on the VHF's database because the nature of the database itself, as you've heard, is very different from what actually happens in a broadcast news show. This is another slide that basically compares how many of the correct documents show up within the top 1, 5, 10, or 50 documents when you're doing retrieval, and compares it to clean text, which is manual transcriptions, and recognizers outputs. So if you did retrieval on a database and you looked at the top position, the number of, the word queries here referred to as the number of relevant documents that were in the top n positions. So you find that there were like 37 relevant ones here and 30 here. So as you go further down and look at the top 10 or top 20, you find more and more that these two match perfectly with one another. So we do believe we can do some amount of good IR work on this data as well. So these were some of the motivations that led us into believing that we can be successful on this data. Okay, so we have a consortium and we have a project, so we have some work to do. So here are the milestones that IBM has set for itself, or the consortium has set for IBM as for year 1. So we're going to be primarily focusing on speech recognition work in English and start to do preliminary work in IR. So apart from just transcribing speech, since we don't have any transcriptions of any of the data in the database, we're going to start to look into accents modeling and pronunciation modeling to some degree. And we know disfluency is a problem, so we're going to start looking at disfluency modeling also. And from the IR perspective, we'll start looking to do topic detection and segmentation and look specifically into the issue of assigning multiple keywords to the same segment. So these are going to be the primary focal points for IBM in the first year. And we hope to have baseline systems and a decent accuracy to report on at the end of the first year, so we can move forward to the other various aspects. Bill can add to this, but for Johns Hopkins, they're going to be primarily focusing on building a Czech speech recognition system and working on how to bootstrap to new languages with very little data, long-term adaptation experiments, and preliminary work on doing the thesaurus translation to Czech. Remember I said that the thesaurus only exists in English, and they haven't done any work on any new languages yet. University of Maryland is going to focus its work on the automated and semi-automated means of thesaurus generation. They're going to be spending a lot of time doing user studies on the scientific value of the archive itself, and also analyzing the current cataloging scheme and suggesting improvements to it, and to see if this is the way to do things, if there is a fundamental problem in the way things are being cataloged, if anything can be done to improve the cataloging scheme, whether it's with respect to speed or accuracy or from a retrieval perspective. Okay, so what are the various research topics that we've come across so far? If you look at automated speech recognition, I mean, this database basically covers everything you can think of. It's got spontaneous speech and emotional speech. It's got lots of whispered speech. There is a significant portion of the database with background noise, meaning like, there are cars going by. The interview was done outside. There are ambulance sirens wailing in the background, all sorts of things like this. Much of the speech is elderly speech, which leads us to totally different point of view of looking at pronunciations. I have listened to at least one really elderly person who is about 83 years old, and quite frankly, it was very difficult to understand what the person said at all, until I could do some kind of lip reading. When I looked at the video, realized this person did not have any teeth, and so all that you were getting out was puffs of air for many of these things. Don't mean to be impolite, but this is pretty much the nature of the database, and we have to figure out a way to deal with this kind of speech. One of the qualities of this particular database is that people tend to switch between languages. Sometimes you know that they're switching to the next language because they're saying, we would say this word this way in Hebrew, and then say the word in Hebrew. In many of the situations, if they were living in Poland, they would start doing the interview in English, and then they would switch to Polish for a while, come back, switch to German for a while. So this leads you to another area of language ID and being able to handle switching between multiple languages. The speech is very heavily accented, so we really have to do something towards modeling the various pronunciations. There are a lot of obscure locations, names, unknown events, locations on maps which don't exist anymore, words in a particular language which also don't exist anymore. And so this is the standard OOV problem that we have to deal with. That's yet another topic to deal with. Continuing on, we have disfluent speech. We need to come up with better metrics to evaluate other than word error rate, because we may get to a point where to do the kind of information retrieval work and search and exploration, word error rate doesn't mean anything anymore. We need to come up with a better metric to see how well we can evaluate or recognize its performance, and say from here we can go on and continue to do other interesting things. There are language models with respect to language model adaptation. Even simply to begin with acoustic segmentation of speakers, so we can extract the interviewer and the interviewee properly enough to do adaptation experiments. And confidence measures, which was very important for subsequent information retrieval work. In the field of information retrieval, again, we have to do segmentation into relatively short partitions or segments. In the past, they have been used to doing segmentations on broadcast news, so there was a significant duration before a person switched to another topic. Here, this is so rapid that they have to get their segmentation to work on relatively short segments. And we're going to have to do language-specific segmentation. Feature selection is another area of research where we can see how we can add uncued changes of language and speaker turns to improve the segmentation accuracy for IR. We would also be looking at some prosodic and lexical features to improve the segmentation accuracy. Particularly for named entity tagging, we're proposing to look at unsupervised adaptation in several iterative learning schemes. And given that we have vast quantities of unannotated text, we have to find a mechanism where we can re-estimate several of our morphological patterns based purely on the unannotated text. And like I mentioned before, same segment has several keywords. So this is something that has never been handled by this technology, and our preliminary experiment showed that this is going to be a tough task. Agreed, we didn't have too much of test data to play with, but it didn't look easy. And we're going to be focusing a lot of our work on maximum entropy models, query expansion, to be able to, in multiple iterative passes, retrieve documents which are more relevant. And document clustering, which is a very important component here, because in the pre-catalog testimonies, we will have enough training data from across speakers to see how different people talk about a particular topic, and we can cluster these documents topic-based, and this is an excellent starting database for us to improve our technology in that direction. So what do we think this project will impact? We believe this data is very typical of real-world data, especially the spontaneous nature of the speech, the accents, the various sources, the multilingual nature of the data, and we couldn't possibly find a better database to develop our technology in. And not only will it help in producing better products that will work in any kind of an environment, in the car, over the telephone, or whatever have you, but this will really make our technology more robust. And it's going to address a wide variety of fields, starting from speech recognition to IR to retrieval to browsing, search, and exploration. So we believe we can make a substantial difference to the way digital archives are currently being cataloged and how you can search through them. And it will significantly improve the time duration it takes to create a new archive, and also how people can access the information in this archive. And we hope that given the multilingual nature of the data, it would lead to new speech and language research efforts across several countries. And once we have something in place, it will enable students and scholars to scan large quantities of this kind of audiovisual data and do their own social studies and economic studies, and what kind of impact the actual content of this database has. Right now, all of the information is there. It's in the spoken audio, but it's not easy to get access to it, and it doesn't have any real social value unless this thing is done. So these are the very ambitious goals of our project, and we hope to get somewhere someday within the next 5 years. That's all I have to say. Any questions?
Does the thesaurus mean that you're trying to build a language translator?
Eventually, we will have at least a thesaurus translator to go from one language to another. But if you're talking about translation of the testimonies from one language to another, no, that's not part of the scope of the project. But we do hope to get to a point where we can query in a language and also retrieve testimonies or relevant documents from another language by translating because the thesaurus terms are already translated. So it would aid multilingual search.
So in the metadata annotation, are you assuming that you have a fixed set of thesaurus terms, or is part of the goal to figure out what thesaurus terms are?
Right now we have a fixed set, but this grows with more testimonies that get cataloged. The names and places will definitely grow. With 4,000, we're already at a number of about 16,000. There are totally about 21,000 thesaurus terms so far, and we're at 16,000 of names and places, and the remaining are concepts. The concepts probably won't grow as fast as the names and locations because you can always take combination of existing concepts to represent a new concept too. But yeah, it will keep growing, and we hope to get to a point. If we're going to say that we're at a point where we can do the automated cataloging of the entire database, we'll definitely add.
But will you try to discover?
Yes, part of the goals will be to discover new.
The place names and the names of people, what fraction of the OV rate do they account for? Do you have a feel for it? Like in the 12% you had for the bad speaker or the 4% for the good speaker?
I think it was about 75%. I don't have the exact number, but a good majority of it was.
And did the people who do the first 4,000 stories, did they keep track of what rate they were adding names and?
Actually, they have much of this information. They can tell you the rate at which the names and places grew and the rates at which the concepts were added. Yeah, VHF has access to this. We don't yet have access to it, but you can get a hold of it.
But they kept track of it?
They kept track of this. The only thing they didn't keep track of was this person is a coherent speaker, this person is not a coherent speaker, and that would have helped us in selecting our testimonies for training data and test data and things like that, but we're going to have to do it painfully.
Okay.
I would have imagined that a large percentage of those 2,000 testimonies would have been made by people whose native language was Yiddish, but I didn't see Yiddish included in the languages you were prepared to
I only presented the top 6 or 7 languages. If you go to VHF's website, they have Yiddish listed there. And this language breakdown basically defines the primary language in which the person who was being interviewed said they wanted to do the interview in. So even though they spoke Yiddish, they may have felt more comfortable doing the interview in another language.
Well, it sounded from some of the examples you gave that they weren't at all comfortable in another language. You might have done better.
So if they did it that way in English and they felt comfortable, it probably would have been a whole lot worse in another language. Yeah, that's true. I should mention that out of the 4,000 catalog testimonies, there was a request that they do, this 4,000 should include a lot of child survivors. So these were many people who came out of the country when they were like 13 or 14 also, and some of them in the 20s. So it's a wide-ranging database, and we haven't really seen what is out there in the database. We've only had a chance to listen to like 1 or 2 speakers, and the rest of it is what we're told. So it remains to be seen.
Again, was an effort in this based on a visual speech. Are you interested in having that secondary channel as a disambiguation?
We looked a little bit at the visual input, the lip reading part of it, to see how much it can help. We don't have any clear answer on, yeah, this improved accuracy by this much, but yeah, we hope to look at that if we can get hold of the video testimonies. We're not yet clear on how we're going to get the data, whether it's going to be just the audio or the video, but if we do get the video, we'll spend some time looking at the audiovisual component of it. One point to keep in mind is that these were all amateur videographers, so sometimes the camera is focused so far away that you can't see too much, you can't see even a lip movement, and the scene is more or less fixed, it's the same person, so in some testimonies you may not really add value to improving the speech recognizer's accuracy. But yes, this is something that we would look at.
The steps that you took in hand segmentation of the data, which of those, together you found that those help performance paramount.
Yeah.
Which ones were most helpful?
Getting rid of all of the disfluent speech, getting rid of the interviewer's speech. So basically, segmentation accuracies, portions where they overlapped a lot of stuttering and stammering. We're pretty okay with emotional speech and low volume speech also. I don't think I got rid of that part, but there wasn't much data. It was like 1 or 2 speakers, so you have to bear that in mind when.
Does the metadata have information about the interviewee's native language?
Yes, it does. Not the metadata, the pre-interview questionnaire.
The pre-interview questionnaire, whatever, yeah. When I said meta, I meant things other than
it may appear in the metadata if the interviewer said, what was your native language?
Okay, no, by metadata I didn't mean the annotation, I meant things other than the audio.
Yeah, you'll have that information.
I'm sure I understood what you were saying about having difficulty tracking topics, because
Okay, so that
10 years ago, when we first started doing word-based topics by the switchboard, one technique that was used was to maintain a topic vector from the 50 or so available topics, which would then be grown through the passage and then trend or decision made based on that.
the point I was trying to make is much of the work is focused on an assumption that this segment of speech is best characterized by this topic. And nobody has spent too much of time saying if there was more than one topic that was spoken in this segment, how well do we do? And so that's a very important component that we're going to miss out. So it's not like people haven't worked on it before. That's not what I was trying to say. It's just that it just moved a little bit in a different direction.
Do you have a sense of what the impact would have been on the error rate if you gave each person being interviewed a page to read of standard text just for adaptation?
The person who was who actually interviewed?
Yeah, before the interview, give everyone a page for adaptation.
This was done by the Visual History Foundation. They had no intentions of doing anything automatically with speech recognition when they did this.
I realized that was the plan, but had they known the potential for speech in advance, that had helped dramatically.
Actually, I think when you can get good amount of clean supervised adaptation data, I don't think so. I think you can, it'll be a tedious process, but you can, if we can get transcriptions, we can get some good segments of clean speech from them, which we can adapt on, and then you can always do an iterative pass and improve.
Usually, when a person starts the interview, he's quiet and starts to speak very slow. Maybe the person to be comfortable, do some like very easy questions. So this kind of part of speech can be in some way what you can be your model.
It's also the same segment that has a lot of speaker turns going back and forth. You have to be careful with, because the person is just starting to speak, so there are a lot of questions being posed, and it can be good to train on the interviewer and sort of eliminate portions afterwards. So we have to see how well it works.
During your talk, you mentioned that you're going to get rid of the transcripts spoken by the interviewer.
Yeah.
The second one is spoken by the interviewer from the transcript. Do you do that because the second one doesn't have any meaningful information here, or do you have any other situations?
I'm sorry, can you repeat that part again? Did we?
Do you do that intentionally?
Do I do what intentionally?
Getting rid of the segments spoken by the
We were just trying to see what can we do to this data, and can we get to a decent error rate so we can actually propose something that might work. That was the goal.
If I were the user, I would be very interested in having the capability of looking at transcript based on the question the interviewer asked.
Right, right. No, this was just to see how well we could do on the person being interviewed, just on the speech of the person being interviewed. But no, there was no other hidden motive.
Perhaps you should clarify that what they're trying to do is adapt the acoustic, the speech recognizer, to the person being interviewed. And in the process of that adaptation, you take away things that the interviewer said and take away things which are clearly going to be emotional or noisy and so on, and then adapt. It doesn't mean that the interviewer's question is removed from the transcript.
No, this was just to get good adaptation data to make our speaker independent models come closer to this particular speaker. So to get the clean data, we try to manually extract the clean data of the speaker. So that was the goal.
So it's not going to be removed from the final output.
So yeah, no. Okay. Yes.
How do you evaluate the performance of the speech recognition?
See, that was one of the goals, research topics too. How are we going to evaluate the performance of our recognizer? If we can get the word error rates of 30% and 40%, and we would say, okay, we're in a range where IR will work pretty well, and we can use that as our metric. Otherwise, this is something we have to work on to see. If we're standing at 70%, 60%, then we probably have to go towards keyword spotting and see how well we do on spotting much of the metadata in the transcripts that the person said. So much of this will become clearer as we get access to more of the data and we can actually start doing our work on this data, but we have to see. Anything else?
Yeah, I'm just curious, how long it takes for a person to transcribe 1 hour of normal speech? I mean, news or something.
Broadcast news?
Yeah, broadcast.
I would say 5 to 8 times real time.
Okay, so then 10 to 12 is not really that bad.
Right. This estimate was obtained on those 2 speakers and what the transcribers felt. They could have also been a little over ambitious in giving us this estimate, so I would say more like, put an upper limit of 15 hours. It might get very difficult too. I mean, if you just don't understand what the person is saying, then what are you going to do? If you start to mark unintelligible everywhere, then we will have lots of these flows.
Exactly. The transcription has errors.
Yeah. German, Polish, Russian, yeah. Yeah. So, which is why I said an ambitious project, but we hope to get somewhere. That's it.
Just speaking of being ambitious, do you have like set goals, say after 5 years, in terms of word error rate?
Oh, of course, not word error rate. In 5 years, we'll be able to catalog the entire database of VHF, and we would have solved speech recognition. No, just the goals that I described. We hope to make some improvements in technology, and if not, at least we expect to discover what are the areas in which we're seriously lacking in, and what can we do with such a huge database, and what are the directions in which we can go in. So much of our goals are based on that direction. We're not saying we'll get to a speech recognition accuracy of 80% at the end of year 5. No, that's not what we're promising.